Okay, so I think we'll go ahead and get things started. Good morning, everyone. Afternoon, evening, depending on where you're tuning in. My name is Vince, and I just want to welcome all of you to this presentation of Novedge's Best of the Best webinar series, brought to you by Novedge, the Design Software Superstore. Before we get things started here, I just want to turn it over to our Rhino sales rep, Bob Thayer, just to say hello and introduce himself, say a few words about the Rhino discount we have in conjunction with this webinar.
Thanks, Vince, and thank you, Brian James, for presenting today. We're looking forward to it, and right now you're seeing a very goofy picture of myself on the on your screen. So I just want to say hello, let you know that I'm the Rhino rep here at Novedge, and feel free to give me a call or email me. I believe Vince will provide my contact information at the end. And looking forward to the webinar, and want to let you know also about the discount we're offering. For those of you who attend the webinar, it's going to be $250 off the list price for Rhino 4.0. So, and also at the request of my boss, I will spare you and not tell you a really bad joke right now, but email me directly for any awful 3D jokes that you may want me to give you. All right, I'm going to turn it back over to Vince, and thanks again, Brian James, for presenting.
Okay, cool. So I want to thank Bob for that little intro there. And I want to thank all of you for joining us today. We're excited not only to present Rhino, but to have Brian James on board with us to present Rhino for us. Just a little background on Brian. He's a training specialist for Robert McNeel and Associates, as well as a professor at the Rhode Island School of Design. Aside from his endless passion for 3D models and rendering, he's also an avid photographer of HDR environments. Needless to say, Brian is truly an expert. We are lucky to have him on board. Brian's going to speak for about the next 40 minutes or so. During that time, everyone will be in listen-only mode, but please feel free to send your questions into the question box. Afterwards, we'll have a brief Q&A to wrap things up. We will be recording this webinar, so if anyone misses anything, it will be made available to all of you, and we'll give you details on how to view it and where to find it. But having said all that, I want to get it turned over to Brian. Brian, are you there?
Yes, I am. Thanks, Vince.
Cool. I'm going to switch it over to you, and we'll go ahead and
switch the presentation.
Yep. And we're off.
All right, let me get this set. Okay, welcome. I am Brian James. I'm a trainer and support specialist for Robert McNeel and Associates full-time, and I also teach at the Rhode Island School of Design in the Industrial Design Department, as Vince mentioned. I'll be doing this presentation / demo of Rhino 4, and my colleague from our Seattle office, Pascal Golay, will be on the chat panel, so you'll be able to type any questions as I'm going along, and Pascal should be able to answer them. I'll try and wrap up with about 15 to 20 minutes to spare so that we can do more questions, but I'll go ahead and begin right now. So what we're going to be doing is modeling a wheel well like you'd see on a car, because this is a typical scenario where you have to meet to certain curves, but you want to create a transition between multiple surfaces. So I'm going to go as slow as I need to have the audience view update. So I have this little preview for the meeting. It tells me when your screens have updated to what I'm seeing, so I may pause and tell you I'm waiting for it to update. But the first thing I'm going to do is draw a CV curve, a control point curve in Rhino. And up in the command line you can see that by default it'll be a degree 3 curve. Now I'm going to click 4 times, so I'm making 4 control points, and I'm in the front view. And I'll end that curve. Now if I turn on the control point structure for it with the F10 key, you'll see that there are 4 control points. If I run the what command and select this curve and press enter, I can see in the geometry section of the what command's object description dialog, and this is, by the way, the same window that would pop up if you clicked Details and Object Properties with something selected. In the geometry section, I can see that there is a degree and also a control point count. So the important part here is that this is degree 3, and the control point count is 1 higher than the degree. So I've got 4 points in degree 3. Now if you follow that rule, what you'll have is what's called a single span curve. And if you have that count and degree relationship in both the U and V direction of the surface, then your surface patch is also considered single span. Now the reason to model with single span when possible is that it creates less of an opportunity for any discontinuity within the curve. So to show you a little bit about what I mean, I'm going to run the command Curvature Graph on this curve that we just drew. And the Curvature Graph dialog comes up, and you can hit these little arrows here for the scale so that you can see the curvature of this curve. Now if you have a straight line coming off of it, or some other curve, and I'll draw it like this, and I add that to the curvature graph, you'll see that this line, and I'll wait for you to see my mouse here. One moment. You'll see that where these spines, or the curve hair, meet up is in line. So it means that we have tangent continuity here. But these lines, the top lines that are representing how curved these lines are, these curves, those don't match up. So we have G1 continuity here. We don't have G2. All right? And this type of discontinuity or bumps in the curvature graph can happen the more points you have. So if you want the simplest possible representation of your shapes, then work in single span when possible. So I'm going to keep coming back to looking at my degree and control point count for both curves and surfaces throughout this demonstration for this sole purpose of working in single span when possible. So I'm going to remove this curve from the curvature graph and turn off its control points. And I'm going to draw another curve, and this curve will be a straight polyline. So it's just going to have 2 points. I'm going to hold down Shift to keep it in a straight line. And if I turn on the control points for it, you can see there's only 2 points, the beginning and end. So I'm going to run the rebuild command. And the rebuild command will tell me how many points it has and what the current degree is for this curve. So it has 2 points and it's degree 1. So degree 1 curve is a straight line. I could rebuild the point count and also change the degree in the rebuild curve dialog. But I can also run a command called change degree, and there's different results that will happen from either rebuild curve or change degree. If I use rebuild curve, all the points will be reshuffled around on the curve. And because it's a straight line, there wouldn't be any change in the shape. But if it's curved, you will change the shape by using rebuild. So if I use change degree instead and select this straight line, I can see up in the command line it says degree 1, same thing that the rebuild dialog told me. I'm going to type degree 3 and press enter. And you'll see as soon as I do that, it gives me 4 points. So you remember from this first curve we looked at, 4 points and degree 3 is a single span. Now we can check how many spans this curve has with one of 2 commands in Rhino, either remove knot or insert knot. I like remove knot, and select the curve. And you'll see that there's only 2 knots. Let me turn off the control points here, make this a little bit more obvious. So there's only 2 knots at the beginning and end, which indicates there's a single span in this curve. If we had another knot in here, we could remove it. But if you follow that degree and control point technique that I mentioned, you'll be working with a single span curve as well. So I'm going to select these 2 points at the top and use scale 1D with a midpoint snap. Like that. Maybe I'll scale these in a little bit as well. And I'll wait for your screens to catch up. Okay. And I'm going to go into the perspective view here. This will take a moment. All right. And you'll see that both of the curves that we've drawn are on the front construction plane. So I'm going to select this curve here and drag it off just a little bit so that we have some distance between what will be the edge of the wheel well and this design line for the rim of the hood. And now I'm going to draw some straight lines. Again, these will be with just 2 points because we know that we can change degree and add control point structure as needed. So I'm going to keep these really simple at first. And I'm going to draw a line from midpoint to perpendicular of that line. And then in my front view, I'm going to draw one curve there and one curve there. And I'm just using my end object snaps to do this, and my smart track to keep everything in a line. And if I turn on the control points for these curves, I'm now in a position that I can start to edit these just to describe the shape. So I'm going to do this in the perspective view, and I'm holding down the control key to move in a straight line, up and down, or the shift key to move in a straight line left to right. I'm going to draw a few more straight lines here. The general idea here is that I'm going to make 2 large 4-sided surfaces, one here. Let me wait for your screen to catch up a little bit here, and one on the bottom. And now that I have these curves that have 2 points in them, I'm going to select all of them at the same time and run change degree again and make them all degree 3. Turn on the control points, and as we saw before, changing to degree 3, these straight lines now have 4 points. And I'm going to describe a little bit of curvature here. Just a little bit so that these aren't completely straight. And I'm also going to add a little bit more of a shape to this end one here. And I'll add the opposite shape to this one here, so it dips in a little bit. There we go. But you can see from the front view that I kept them in a straight line. Again, that was using the shift key and the control key. Control if I'm in the perspective view to keep in a straight line with the z-axis. I'm going to maximize the perspective view and turn off my control points, and I'll wait for your screen to update here. And I'm going to draw another curve. This time, instead of a CV curve, I'm going to draw what's called an interpolated curve. The command is interp curve, or if you get the flyout for the curve tools, it's this second one in here. And the interp curve command lets me pick these endpoints so that I'm describing a curve that passes through those endpoints. I'm going to select that bottom curve and run the what command. And I can check out that it has degree 3, but it has 5 points. So if we run that remove not command, I can see that there is a knot right at that middle point that I interpolated through. So I can either remove that knot or I could rebuild this curve. In either case, I will be changing the curve slightly by doing that. I'm going to run rebuild and do it that way. In parentheses, you can see, I'll wait for you to see it, you can see the current point count as well as the current degree. I'm going to make it 4 points instead. And here I'm going to click Preview. And in max deviation, I can see that given my model units, the deviation for this rebuilt curve would be 7/1000ths of a model unit. So I'm going to accept that deviation. And next, I'm going to select this top one here and split it. You'll recall that this had 3 points, or 4 points rather, and was degree 3. I'm going to split it with this curve here. and it split it into two pieces. So if I run the what command on the split part, or the split curve, you'll see that it has the same structure as the original curve. It's degree 3 and has 4 points. Now I know that since I didn't split either of these 4 curves around the border, those are all still degree 3 with 4 points, and we're ready to make our initial surfaces. I'm going to use this tool here, which is in the Surface Floating toolbar. If you don't have this readily available to you, you can right-click over any empty space next to the toolbars, and you can go down through the list. It's alphabetical, and you can pick the appropriate toolbars that you'd like floating, and then just keep them around or dock them if you'd like. But I'm going to use this second icon in on the Surface toolbar, which is the Edge Surf command. So Edge SRF is the command. You can pick 2, 3, or 4 as the command line says. So that's our first surface. And if I run the what command on it, you'll see that it has the structure of the curves that define it. So it is degree 3 with 4 points in the u direction and the same in the v direction. And I'm also going to run Edge Surf again on this other set and quickly run the what command so you can see that that also is the same structure. And I'll wait for your screens to catch up. Degree 3 and 4 points. Now I've got a special analysis mode here that I've set up, and I've made it so that the u direction of the surface is displayed as this red line and the v direction is displayed as green. If that's of interest to people, I can show you that at the very end, how to change your display mode properties. But this custom display mode is something I'll be going to so that you can see the structure even though we're in a web meeting. I'm also going to be displaying several analysis modes. So the first one is zebra is the command. And if I display that, you'll see this zebra map that happens. And let me select that curve and hide it in the middle so that you can see the break as these zebra lines travel between the surfaces. So that indicates that we don't have continuity across these surfaces. So this detail line is what I want to blend out into a flare for the wheel well. Now you see how it's jagged here in the zebra map? That's the render mesh that's being used for analysis. And you can click on Adjust Mesh, and we can click on Detailed Controls here. And there are many different theories of how to set these values. And that is the method that I'm going to use for right now. And so you can see that that was just a mesh setting that made it look jaggy. But we want to blend out this discontinuity between the surfaces. Okay, the next step is going to be to offset this wheel well curve in 2 directions. So I'm going to run the command offset, hit the letter T for through a point. I'll hold down Alt to temporarily disable my object snaps. And I'm also going to do it in the other direction as well. So I've made 2 offsets like this. And for these 2 first curves, and I'll wait for your screen to update here. For these 2 first curves, I'm going to run the Loft command. And if you leave it on the default setting, it'll say do not simplify. And if I zoom in here in the perspective view, I'll wait for this to update for you. You'll see that if I don't simplify, the isocurves or the isoparms for the surface are tilted as they travel around between the 2 lofted profiles. If I click Rebuild, and I'll use 10 points, I get a more well-ordered structure for the surface, so I'm going to rebuild it. Say OK. And I no longer need those curves, so I'll hide them with the hide command. And I'm going to take this surface, and I want to describe a transition between what will be a cut line from this other offset curve out to where this flat rim of the wheel well is. So I'm going to drag it out to the side so that I have a little bit of distance to transition with. And I held down the Shift key to stay in a straight line while dragging in the perspective view. And then I'm going to take this other curve that was our offset curve, and I'm going to use it to trim each of these surfaces. And you'll notice, given your geometry, if it doesn't go all the way past the surface, you can see in the front view here, you won't be able to trim. So I will run the command extend. And if you read the prompt in the command line, there's an option just to press enter for dynamic extend. So I'm going to press enter, then select my curve, and I could type in a value or just use the last used value by pressing enter. So it extends it 1 naturally or smooth. And enter to end that, and then I'll select this curve and use it to trim that bottom surface now that it passes all the way by it. And I'll wait for your screens to update. I'll also hide that trimming curve. I no longer need it. And I'll maximize that perspective viewport. I can also hide some of those original curves as well. And now we're ready to draw some initial construction lines for these two surfaces. So there's going to be 2 more patch surfaces. And I'm going to use straight lines again, 2 points. And I'm going to go right to the mid-snap of the wheel well there. And in the middle, I'm going to use that perpendicular object snap to come right to the wheel well perpendicular. And now that I have these cross-section curves laid out, I want to show you a couple different ways that you could make these initial surfaces. And this is where the details of where control points are in a surface have a lot to do with the results that you'll get when we go further into matching adjacent surface continuity. So if we were to use edge surf, which is the first surface command we used for these first 2, you'll see I get this whole surface edge here, so I'm going to escape out of that and use the command split edge. Grab this edge and split it at endpoint snaps there and there. And now if I use edge surf, I'll be able to select just that portion of the wheel well edge. And you can see the surface that it creates. So the top and bottom here in the V direction of the surface were straight lines, and the red lines here in the U direction of the surface are matching up to the input on either end, which is this trimmed edge or this surface edge here of the loft. And because they're curved, it needs that much information by default to stick to it, to be in the same spot as it. And if I turn on the control points for this surface, and I'll wait for your screens to catch up here, you can see that the arrangement of the control points is not perfectly even. And we could rebuild this to try and get a more even display of control points. And I'll do that first, just so you can see what this looks like. And I'm going to rebuild it to 6 points by 6 points, degree 5 by degree 5. So you remember, 1 more point, then degree, and we'll have a single span. And you can see the arrangement is not that bad. It looks pretty even. Everything is nice. Now, depending on your geometry, what you're actually blending between here, or what your surface boundaries are, this order could be shuffled. It might not look as even as it does now. And what you really want is you want it as even as possible before you start using match surf, which is what we're going to do. And one way to do that, I'm going to turn off the control points and delete the surface, is to use a different surface creation technique first that gives us a more even arrangement of control points by default. And that's sweep to rail. So if I use sweep to rail here, 1 rail, 2 rail, and I'll wait for your screen to catch up here. And then I'm going to select the cross sections, those straight lines that we drew. And I'll leave it on position continuity for both edges. you can see by default the isocurves have a much more orderly display. And if I turn on the control points, those are also more well-spaced or more evenly spaced than the edge surf result. And now if I were to rebuild, looks pretty much the same in this case, but I wanted to give you that alternate method of creating this initial surface. You want the control point structure to be as clean as possible, and that's the general idea. And we're going to do the same thing up top for this second patch surface here. One rail, two rail, cross-section and cross-section. And I'm going to rebuild this as well. And turn on the control points just to make sure they look pretty even. And I'm going to select all these surfaces and run another analysis command called emap, or environment map. It's one of my favorites. It has this drop-down list of all these different environment maps you can put on the surfaces. And you can choose whether or not with this checkbox here to display the isocurves. Now my custom analysis mode has some transparency as well, so you can see the control polygon of the surfaces through it. So you can see the structure of the surfaces that we just made, as well as the environment map on it. And now I'm going to use a command called match SRF, or match surface. And it's this icon here. I'll wait for your screens to update. In the surface tools toolbar that's floating, and just follow the prompts in the command line. And the first match that I want to do is between this edge and the adjacent edge here. And match surface comes up, and I want curvature continuity. And I'm also going to preserve the isocurve direction. So the isocurve direction, that evenness that we had in this surface, I want to preserve that. And if you have refine match on, it could possibly add a knot to the surface. So keep that in mind, but it does make a little bit of a better match in some cases, in my opinion. And you can see what happens there. We've now matched continuity between that surface. Let me wait for your screens to catch up so you actually can see this. So we have continuity between these two surfaces now. And I'll throw a zebra map on that as well, so you can see that continuity. And I'll wait for your screens to catch up. One moment. It's still not caught up yet for you, so I don't want to proceed until I see it. Okay, there we go. We've got about 200 people watching this right now, so I'm not sure if that affects the speed, but on the update, I'm sure it doesn't help. So I'll try and go slow so this is useful for all of you. And it looks like your screens are caught up now. So the next match that I'm going to do will be for the top surface. So again, I'll run match surf. Select that top edge and the adjacent surface, and I'll use those same settings. Curvature, match edges by closest point, and preserve isocurve direction. That match edges by closest point option is really useful if you don't want it to stretch to the entire edge, but in this case it's the same distance. And I'll wait for your screens to catch up. So you can see that we have curvature continuity on the top as well now as on that side. I'm going to zoom in on the treble spot. And I'll display my isocurves for the zebra map here so that you can really see this. And I'll wait till that highlights for you. So that gap between the two surfaces that I just matched continuity with for the original two surfaces, that gap is what we're going to struggle in blending out. unless you know how to do it. It's not a big struggle if you follow this technique. So what I'm going to do is I'm going to split this top surface here by isocurve. So run the split command and click on the isocurve option up in the command line. I'm going to toggle the direction of the split so it's the other direction. And I had shrink equals yes on that split. And the reason that's important is that if I run the what command on this surface that I just split out, you can see that it has the same structure as the surface that it came from. So if you have shrink equals yes on, then it will inherit that structure of degree 5 and control point of 6. So we have single span in both directions still. I'm going to disable my isocurves here, display for the zebra map options, and zoom in here on the area of interest, and you can see that discontinuity, that split that's happening right there. So I'm going to use match surf, and I'm just going to hazard a guess. It all changes depending on your geometry, but I bet there isn't enough information for it to accurately match curvature along this edge as well as position along the wheel well edge. So let's see. We'll give it a shot first, and I'm going to try match surf, and I'll keep those same settings as before. Oops. But I want to make sure that I move that edge. So if you get a selection menu, it'll show you the arrows for which surface you're about to change. So I did the wrong one first. So this is the one I want to change, and that's the one I want to match. And you can see, hopefully, in this web presentation, I'll show the isocurves for a second. That makes it a little bit easier to see this. You can see that when I match curvature continuity across that edge, I create a positional gap with the wheel well edge. And that's a pretty big gap. If I match to position right now, I'll probably destroy this curvature continuity. So just from experience, I know that that's probably a little bit too big, but I'll show you what I mean. If we use match surface again, and I change that one to match that one, and this time I choose position as the continuity type, and I'll disable my isocurve display. It's not bad, but let me see if I can hone in on a view that shows it. And I'll wait for your screens to catch up here. I'm a very detail-oriented person, so you might think this is overkill here, but there's a little bit of a discontinuity right at the edge here. And I'm going to hopefully, you'll see where my mouse is moving there. Right at where the juncture of these two surfaces meet the wheel well, there's a little bit of a discontinuity. So before I do that match, I'm going to take this surface and rebuild it to have more points in the U direction. Or let's make sure that's the U direction, yes. So this red line, and I'll wait for your screens to update. I sound like a broken record, but it's better to catch myself than keep going forward. That red line here indicates that the U direction could use more points so that it can keep to position along the wheel well as well as curvature along here. So I'm going to select that surface and type rebuild, and I'm going to raise it to 8 points in the U direction, and to keep it as a single span, I'll change the degree to 7. I'll say OK. Disable the isocurve display for the zebra map and run match surf again. Let's see. And that's the edge to change and the edge to match. Pick curvature. And then I'm also going to match curvature on, well, I don't need to, it doesn't look like, on the other end, so I'm just going to go right into matching position. So I have a less of a gap here than I did before. I'm going to go back to this edge, and sometimes it helps to just go to a positional match or do the curvature match again. And I'm going to do it on the other end too. Curvature match. I'm going to click Preserve Opposite End here. And this is what I was talking about. If it doesn't work exactly for you, you can raise the control point count by rebuilding that surface. But that's pretty good, so I'm going to leave it like that and proceed because I'm running out of time here. But I can run the what command just to make sure that we're still dealing with single spans. You can see that with refine on, it is added, given this curvature, it is added a control point in one direction. And that would be in that U direction there. But I'll leave it like this for now, just so that we can continue with this. Okay, so now I'm going to trim off the part that is not matched at the top here. So rather than try and match to this edge as well, I'm going to trim this off with a straight line. So I'm going to use the extend command again, dynamic extend, and I'm going to use the line option and pick this edge here. I'll wait for your screens to update. And then I'm going to take that curve that we just made and the surface. I'm going to run the pull command to pull it up like that to that surface. And then I'm going to use the trim command to trim off that area. And I'll wait for your screens to update here. Next, I'm going to take that top surface and I'm going to run extract isocurve and use my end object snaps, T for toggle the direction, and grab two isocurves off of there, and then use the trim command and then delete those isocurves. So that I'm left with this rectangular boundary here. And now I could use edge surf. And if I select that edge, you'll see it grabs the whole thing again. So I could either use sweep to rail or I could split that edge. I'll split it. So I'm going to run split edge on this edge and grab that endpoint. And then I'll use edge surf. And you can see the isocurve structure. The isoparms are indicating an uneven display, or uneven arrangement, rather, of the control points. So I'm going to rebuild this. And I'm going to make it 6 by 6, degree 5 by degree 5. And then start matching. Now I can disable my isocurve display here so that you can actually see that discontinuity that's happening on the three sides. And I'll get into a view that shows it for all three sides. And I'm going to run match surf now. Once again, I'm going to start at the top here and do a curvature match. Then I'll move off to the side. And then I'll do this side too. And you can see that the top shuffled in that last change, so I'm going to go back to the top and do a tangency match. And that snugs that up on the top. Now I didn't care about this edge right here. Let me turn on my isocurves again for zebra map so you can see this. So the edge between those two surfaces still has a gap, but we're going to remove that information. So I'm not too concerned about that at the moment. And the way we're going to remove that information is by creating a duplicate edge and offsetting it on surface and then extending it to the outer borders. So I'm going to start by dupe edge, select one of these edges, either one will do, enter, and then I'm going to run the command offset curve on surface, offset curve on SRF. And let me wait for your screens to catch up here. And I click on the base surface. It gives me arrows for the direction that it's going to offset. And there's a numeric value we can pick whatever we want, and that's a little too big, so I'm going to do it again. Type 0.3, and I'll do offset curve on surf for the other direction as well. Same distance, like that. Let me display my isocurves and wait for your screens to catch up here. So I'm going to zoom in on that area, and I'm going to take each of these curves that were offset on the surface. I'm going to extend them over to this far edge. So I'm going to use the extend command again, press enter for dynamic extend, and change the type to smooth. And then I'm going to pick that curve, and using my near snap or perpendicular snap, I'm going to take each one over to that opposite edge. And I'm flaring it out on purpose so that I give it a little bit more breathing room so that it can settle out. You could do it straight across, but it makes it a little bit tougher to match continuity across this third side perfectly. So flaring it out like this is a useful technique. I'm going to select both of those curves and use the pull command and pull them to all these different surfaces that we have here. And then I'm immediately going to run the join command. And the command line reports back joined into two open curves, so I know that we don't have any gaps right here when it passes across these surface edges. And now I'll run the trim command and trim off the portions that I don't want and hide my cutting curves. And I'll wait for your screens to update here. And now what we're going to do is use blend surface, blend SRF, to blend between these two trim edges that we've created, because blend SRF is great for working across multiple edges. So I'm going to run blend SRF, and it's this command here, blend surface. I have auto chain equals yes on, and my chain continuity type is tangency. It's nice to use auto chain here because it lets me know that I have continuity right across these two surfaces, at least of the G1 type. And so that's our first edge, and then our second edge, and then enter. And I'll click preview here and wait for your screens to update so that you can see these isocurves or isoparms and how they're a little bit twisted. Now, blend surface has these continuity options up in the command line, and you see it says G2 for both. So we have curvature continuity across edge 1 and edge 2. I'm going to adjust these handles, and I'm going to click on that middle point for the handle for edge 1, hold down the Alt key, and left click. And this allows me to twist, and then I'm using an end snap on the adjacent end of edge 2. And I'll do the same thing, hold down Alt, click on that middle handle, and get an end snap. And that straightens it out right there. And I'm going to do the same thing on the other side. Hold down Alt, click on the middle one, get an end snap, hold down Alt, rinse and repeat. And if we zoom in here, you can see that we're a little bit twisty in the isocurves. So up in the command line, I'm going to use, and I'll wait for your screen to catch up, I'm going to use that Add Shapes option, just like that, to add a shape to control how the blend will be. Now I'm still in the middle of the blend surface command, so I'm going to press enter. And at this point, we could adjust where this is. And I'm going to leave it the way it is for right now. I think that's okay. And I'll add objects, display my isocurves. And right here at the end, I want a positional match, so I'm going to match right there. And you'll see it ripped it up. So that's because that edge right there needs to be merged and split, because we did some other stuff there before. So merge edge is the command, and then split edge, And then I'm going to use my end snaps. And now I'm ready to do that match. And that'll be a positional match, like that. And we could even try tangency match. And I just don't want to rip it apart too much from the adjacent borders that we have curvature continuity to. So if I was going to be really finicky about this, and I'll display my isocurves here, I would now split out some sections here where it's twisting, because that indicates that I'm expecting too much from the surface here in that direction. And it's hard to keep the continuity across all three of those edges. So I would split out another section and do match surf there. But I want to keep us at least in time for some questions here. So last thing that I'll do is make sure that everything joins together. So I'll run join, run the show edges command, and I just have my edges highlighted for naked edges. I don't have any gaps in there, so that's good. And I think lastly, the way that I would deal with this hard edge here on the wheel well is to just use fillet edge. And I'm going to turn on that EMAP display again and show you one of those other display modes. I'm going to wait for your screen to catch up here. This display mode of fluorescent tube is really useful. You can slowly track and see this reflective line that passes down. So that was really quick, and hopefully it was useful to you all. So I'd like to open the lines now to questions. Maybe Pascal, you can shout out any questions from
here.
the chat window.
I'll get to some here. The first one I want to get to, what's the difference between merged edge and joined to naked edges?
That's a good question. I generally don't use joined to naked edges. Pascal, do you have an opinion on that difference? Pascal might not have his...
Yep. No, I'm here. Merging edges is merging adjacent edges of a single surface. Joining two naked edges, joins two surfaces that have opposite edges. Does that make sense?
Yeah, no, that's perfect. Let's get to another one here. Why would you not sweep that elongated area rather than blend the surface?
You absolutely could. The nice part about blend surface is that it gives you the ability of adjusting those handles with that holding down the Alt key, which I kind of like for making that in a straight line, especially if I were to chop out some portions and do additional blend surfaces. There, it's really nice to be able to zoom in, adjust the handles for how the blend is happening. We left it to the default of a power of 1 across edge 1 and edge 2. But sweep to rail is perfectly valid because it does give you that curvature option as well and the chain edges option.
Okay, cool. Frederico is wondering, will you show your UV red-green view settings?
Oh yeah, sure. So if you open up Rhino options, and let me wait for your screen to update here, it's in Rhino options, appearance, advanced settings. These are all your display modes. So the way that I usually do it if I'm going to make a custom display mode, I built this off of Ghosted. So you go into advanced settings here, you pick Ghosted, and you choose copy, and then you'll immediately be in the settings for it. So I copied Ghosted, I named it Analyze, and under here you can change all sorts of stuff. So for surfaces, so it's the display mode, objects, surfaces, there's these drop-down lists for isocurve color usage, and you can pick colors. And I find it really useful so that you don't have to jump back and forth from the direction command, the dir command.
Okay, cool. Ernest is wondering...
Hopefully that made sense.
Yeah, no, that was good. Ernest is wondering, is there a good reason other than time not to repeat match surface with refine over and over? Does it not continually get better and better?
No, it won't get better and better, and that's exactly what I thought for a very long time. So So you're right in thinking that, I think. But match surface uses the arrangement of the control points. So if the control points are all crazy and you keep using match surface, it's just going to get crazier and crazier. So that's why you want to have the arrangement of the control points as even and cool as possible before you use match surf. And with refine on in match surf, the arrangement can shuffle a little bit in a way that you wouldn't think it should, and if you keep doing match surface, it's just kind of build on that current arrangement.
Okay, cool. Martin has a question here. How do you remove a knot without affecting the redirection of the curve?
I'm not sure you can. I don't think you can. I mean, there's going to be some sort of deviation. And you could, is it true, Pascal, that you think you could get close to what the deviation would be just by going into the rebuild dialog, changing it, and clicking on preview?
Compared to removing a knot?
Yeah.
No.
I mean, well, what the resulting deviation would be if you just pulled the knot out?
No. It will always change the shape if you remove a knot. Adding does not. Doesn't change anything about the shape in space of the object.
Right.
Okay, cool. Interesting.
And that's why change degree won't change the shape. You go up.
That's correct. That's why sometimes it's preferable to rebuilding.
Yeah. Okay, Vince.
We'll get to a few more here. Adam was wondering, what is your interpretation of the misalignment of the red isoparm between the lower two aligned surfaces?
Oh, it's really probably due to the fact that I added one more control point in one of the directions here. That's what I would guess. Don't get hung up on that stuff, though. I mean, go into the analysis mode, and if it looks good, it looks good. I tried to stay with single-span surfaces here just because, you know, if you search for this type of modeling technique with surface modelers, you'll see there's a lot of belief that this is, you know, the end-all be-all of surface modeling. But I think if it looks good and it captures your design, you shouldn't be too hung up on having single-span. Yeah.
I think one reason that might have occurred if the surfaces are actually the same is that you had on some of your matches, and I was trying to answer questions, so I'm not sure you did, but you had match by closest point. It may have been set, and that would not allow those to align up. If you don't set that and the surfaces match up nicely in terms of their structure, then the isocurve will also.
Right. In short, practice makes perfect. And all this stuff, you're going to find different workflows depending on the geometry. I mean, it's if there was one case that worked all the time, that's all we would teach. But it's often very dependent upon the geometry. The main thing I was trying to do here was hold to some of these design curves. So I had that initial curve, the wheel well arc, and that straight line at the back of what would be the door or some adjacent geometry of the body. So holding to those plus doing this blend out detail.
Okay, cool. Here's another one. Felipe was once told never to do 3 edge surfaces, just 4 edges. What is your view on this? I guess both of you guys.
I agree. When I'm teaching new students, one of the metaphors that I use is that you can think of surfaces as sheets of graph paper. And they're 4-sided sheets of graph paper, and you've got this notebook, and you can rip out as many sheets and use them as you want, but they inherently, no matter what they look like on the screen, want to be and think they are these 4-sided pieces of graph paper. So in the case of like a spherical surface, you've got the poles of the sphere are 0-dimension sides. So it's still a 4-sided piece of graph paper, but it has these 0-dimension sides. And if you make a 3-sided surface, depending on the surface command that you use to make it, you could either have a you could have a 0-dimension side, or you could have a trim surface. You know, so this surface here, the one that's obviously trimmed here, even though it has 4 sides, is a trimmed surface. You know, we could make that as a 4-sided surface, and in some cases that actually helps match continuity as well. But in short, yes, I agree. Use that 4-sided metaphor, and you'll get cleaner geometry.
Great. And then one last quick one here. Do you use network surfaces?
I do. When I'm not trying to get all perfectly clean, geeky, single-span surfaces, network surface is a beautiful command. It does some amazing stuff, but it will give you a lot of control points. And a lot of control points mean many spans in a lot of cases, and many spans mean more of an opportunity for discontinuities, bumps and valleys and such. And you'll see that the cleaner you can keep it, the smoother everything's going to look, especially when you're matching between like 3 edges.
Okay, cool. So I'm going to switch the screen back to my screen.
Okay.
Sorry for everyone who didn't get their question answered. We just...
Oh, let me say, Vince, anybody listening, watching, can email me directly at brian.james@mcneel.com at any time. Our tech support is free, as usual. So that's brian.james@mcneel.com. All right, thanks, Vince.
Cool. So I'm going to switch it over to me, and I'll give you guys some details on where to find this recorded webinar. So cool. I want to thank you, Brian, again, and Pascal for helping out with the questions there. I want to thank all of you who attended this presentation of Novedge's the Best Webinar Series. Just a little background on Novedge, in case you're unfamiliar. We're the leading online design software superstore. Not only do we have the best prices around, our staff is extremely awesome. You can call, chat with us anytime. You guys all got introduced to Bob. He's really an expert, knows his Rhino. If you're looking for any Rhino products, he's really the best guy. Anything Rhino related, he could definitely help you out. Those of you may know already, Bob mentioned it, you will get $250 off the list price of Rhino for attending this webinar. You'll receive an email from us with the coupon if you're interested. That'll be coming within the next 24 hours or so. But yeah, so $250 off the list price. So watch your emails for that. Another thing I'd like to draw your attention to is another thing here at Novedge that we love to do is go above and beyond for the design community. In doing so, we've created several communities to foster the collaboration, communication between design professionals. One such community, Rhino Jungle, you can see it on your screen here, is tailored specifically for Rhino users. If you're not a member, it's free, it's easy to sign up. You have instant access to all the latest trends, videos, news, events, tutorials, all sorts of things. There's a great forum on there. If you have any questions, you can send them in there, and the community members love to help out one another. This webinar will be recorded and made available there, and I'll send you guys the link to the email, or I'll send you an email with the link, on how to find it. So yeah, I mean, Brian, is there anything else you want to add really quick before we sign off here?
No. Thanks, everybody, for watching. And if you have any questions, let us know.
Cool. So, yeah, thank everyone out there, and we'll catch you next time.
All right. Bye.